So this is section 1.4 out of our book. We're going to start on functions, and functions is probably one of the most important and least understood or recognized type of work. I mean, it just seems so basic, but there's so much that's embedded into it. And I think some of the things that we're going to do are new things, and some of them are going to be a rehash of things that you already know. So we are going to talk about what functions are and how they work. So make sure that we pay close attention to some of this definition stuff, things that you have learned before, but you probably have not used very often. So we're going to redefine a lot of that stuff. So also you want to pay attention to what's on the screen here, because there is some formatting glitches on your paper. So you want to make sure that you rewrite what you see on the screen, because if you look on your paper, it's probably going to be a little bit confusing. So let's start off with what we have here. So in this screen and on your paper, you see that we're talking about what a relation is and what a function is. So there are two different things. When we talk about a relation, a rule, it's basically just saying a rule that relates two quantities. Any input can have any number of outputs. What does that mean? It means that basically whatever we put here, it can be a relation. It doesn't have to be a function. We're not going to call it a function yet, okay? But we can put anything we want in. If we put in 2, we may get 3 and 4 as an output, okay? And then if we want to put in, say, 5, we might get 12, -5, and 6 as an output. That's all a relation is. You have an input, goes through a little machine, and it gives you an output. For a function, and I know that part of this is covered up, but you can see it on your paper, a function is a special type of relation where every input can only have one output. Meaning, let's just use an example of a function. So a function that we are aware of is, say, x plus 2. If I input a value, 2, then when I plug that into the machine here, 2 goes in for x, because our input is typically x and our output is typically y for anything. So 2 goes in for x, 2 plus 2 is 4, our output is 4. If I want to put something different in, say like 5, well, that goes into the machine. 5 plus 2 is 7. And you can recognize from at least this type of function that no matter what we put in for x, we are only getting exactly one output for what we get. Okay? That doesn't mean that outputs can't repeat. It just means that we are only getting one answer for every input that we put in. So it really is important for us to know what things are functions and what things are not functions. So on this one, this is where you need to pay a little bit of attention. We have a little bit of a glitch here with how this looks. So what we're going to do is we need to actually move some of these arrows. So I'm going to do that real quick here. But again, we're not going to spend too much time on this, just so you can kind of understand what's going on here. So what we have here is these arrows are supposed to go like you see right now. 1 is supposed to go to 6, 2 and 3 are supposed to go to 8, and 4 is supposed to go to 9. So the question is this a function, yes or no? Well, what we have to look at is look at all of our inputs. 1 goes to 6, 2 goes to 8, 3 goes to 8, and 4 goes to 9. So because every one of our inputs is only going to one value over here, remember, it doesn't matter that this is repeated, it means that we only are going to one value, then yes, this is a function. Okay, and then if you recall domain, we can now identify our domain a little bit differently. We're used to using domain things like x is greater than 0, and that's okay. But in something like this little machine you have, your input is the only domain that you have. So we write little brackets and we say 1, 2, 3, and 4 is our domain, because that's what our input values are. For our range, we're going to do that a little bit differently, because even though we have 6, 7, 8, 9 over here, you see the results that we get are only 6, 8, and 9. So our range here is just going to be 6, 8, and 9. And that's how we define domain and range. Now, when we deal with actual functions, it encompasses more values. That's why you see things like x is greater than 0 or y is greater than 0, stuff like that. So let's move on. So here's more things about functions. Are the following organizers functions? Here's another place where you're going to have to kind of make an adjustment on your paper. What it did on your paper is it looks like the negative skipped a line and then it went down to 2. So you may just want to rewrite these real quick. So if you have to pause the video to rewrite them real quick, it won't take you that long, but I'm just going to move on. So in this one, we got to look at our input values. So look at all of our input values. 2 equals -4. 3 is -1. 3 is 4, 5 is 6, and 7 is 9. So we have to ask ourselves, is this a function? And you should be able to answer no, because it looks like we have 3 going to negative 1, and we have 3 going to 4. So the input value of 3 is yielding 2 different outputs. So no, this is not a function. In part B, again, reformat that, rewrite it if you need to. This one, we're looking at all of our inputs. Notice all of our inputs are different, and they all go to exactly one output. So in this one, absolutely yes, this is a function. In our last one, this is a little bit more difficult, but I'm going to say less difficult in the long run because we're just looking at a graph. So how do we determine whether a graph is a function? You see this black vertical line here, and this is what we call the vertical line test. And you may have done this before in a class, but basically what the vertical line test tells us is it wants us to draw a vertical line anywhere on the graph. And keep in mind, when we draw a vertical line, all that does is represent an x value. So that is our input value. And what we're looking for is, does that line intersect more than one point on any given line? This only goes through 1 point. This only goes through 1 point. 1 point, 1 point. So that passes the vertical line test, so we can say that yes, this is a function. Okay, moving to the next slide, you can see a different type of graph here, although this is a little bit messed up. It should look like, let's see if I can just move this real quick. This should look more like this with our axes. That's not a very good line. I'm not going to be able to draw a very good line here, but there's our axes. Okay, we have our circle. Now again, look at our circle. There's our vertical line. Is it going through more than one point? We have a point that it's going through here, and we have a point that it's going through here. So because it's going through more than one y value, our vertical line is the one input value, and it's going through multiple points. So no, this is not a function, because it's going through multiple points for each input is giving us multiple outputs. So now let's talk about it in story problem form. So let's say if you have a student ID, everyone has a student ID, and then that's going to be your inputs. Your outputs is going to be scores on an exam. So the question is every student ID different? Because if it is, then every student ID should have exactly one score. You as a student are never going to you're never going to have multiple scores on the physics exam. So if you don't have multiple scores, then this is absolutely a function, because for every input, every student ID will give us exactly one exam score. Now again, that doesn't mean that exam scores may not be the same. We could have student ID 2000000, and they got a 93. And then 200000001 got a 93 as well. But these are the inputs, and because the inputs are different, we're getting exactly one output for each of them. Therefore, it's still a function. Very, very important for you to understand the difference between a function and a non-function. Okay, so let's talk a little bit about function notation. So I know you guys are familiar with function notation, but what we want to do is we want to start bringing in some more complicated ideas of function notation. What you see here, this is equation notation. This right here is function notation. The symbol f of x is red. F of x, not f times x. It's f of x. And basically it's interpreted as the value of a function at the value of x. Okay, so whatever the value of x is, that's what the value of our function is, or that's how we determine the value of our function. X is always the input, y typically the output. We call x the independent variable because it's independent. You can put whatever you want in for it. And y, the output, is the dependent variable because it depends on what you plug in for your independent variable. Okay, so let's take a look at this with a couple of examples. So we have our function x squared plus 8x minus 2. What is g of 6? Well, it just means that 6 is going to be our input. So that means we have 6 squared plus 8 times 6 minus 2. So 36 plus 48 minus 2. And the value of that is, when you put it into a calculator or do the math in your head, is 82. So g of 6 equals 82. Well, what happens when we just don't have a value anymore? What happens if we actually put a different function? Well, we do it the exact same way. It's going to be negative 4x squared plus 8 times negative 4x minus 2. All we are doing is changing what our input value is. Up here, our input values are x. Down here, our input values are now negative 4x. So we just replace the input value with whatever's our input value is supposed to be. So now we evaluate this. Negative 4x squared, we have to square both terms. Negative 4 squared is 16. X squared is x squared. I'm not going to put a plus there. 8 times negative 4x is negative 32x, and then minus 2. And then that's as simplified as it gets. Let's look at one more example on the next slide. Okay, we have g of 5c plus 4. So again, no different. We're just going to input it a little bit different. So there's our input. It's not x anymore. It's now 5c plus 4. So therefore we go 5c plus 4 squared plus 8 times 5c plus 4 minus 2. And then we simplify. We have 5c plus 4 times 5c plus 4. Please do not tell me that this is 25c squared plus 16. It is absolutely not. You have to FOIL. Plus 40c plus 32 minus 2. So now we FOIL this. We get 25c squared plus 20c plus 20c plus 16 plus 40c, and then this 32 minus 2 equals 30. And now we combine like terms. 25c squared, 20 and 20 is 40, plus another 40 is 80, so we have 80c, and then 16 and 30 is 46. So there's our simplified function. So you should understand what function form is, and just understand that whatever's in the parentheses is just representative of an input. So that is what you are inputting in for your x's. Why is this x up here? Because that's what the input says it is. So when we change the input, we just change the input here. Okay? We have to get good at this. This is really important for calculus. Okay, moving on. So the next thing that we want to talk about is piecewise functions. So in piecewise functions, this is a common issue. A piecewise function, and we can read this, in mathematics, a piecewise function is a function which is defined by multiple sub-functions, each sub-function applying to a certain interval. That's probably like to you, blah, 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 blah. I get it. What it's basically saying is we have multiple equations or multiple functions at different intervals on the graph. So what you see in this picture right here is you see a piecewise function. Why? Because we have different parts of a function at different intervals. So what do we mean by that? Well, if you look at this line right here, this line is a certain interval on our graph. And you remember what we did was we did interval notation. So if you look at this graph, we are going from negative infinity all the way to, let's say, negative 3, I don't know, this would be negative 2. So let's say negative 3. And there's an open hole there, so that is not included. The next interval right here is from negative 3, which is included, to 0, which is included. And then our last part of our function is from 0, which is not included, to positive infinity. And you know that infinity and negative infinity are never included. So basically what's going to happen is we're going to write out piecewise functions over these intervals, and we're going to have a function that is applied for this interval, whatever this function would be. And then we have another function that would be applied for this interval. And then another function that would be applied for this interval. Okay? So with that are going to come equations. All right, so it's going to take a little bit more than 15 minutes to finish this. We're at about 14:30. There's going to be a part 2 to this video, so this is wrapped up, and then make sure you start part 2.